these, and then
Yeah.
so shall I write the numbers I need to write first? So
Okay.
4, 11, um, 20, 26, um, 49. Oh no, that's wrong. Sorry.
Yeah.
Uh, 59. 76 and 80.
Okay, what's next?
So now, uh,
Hold on. There should be 61, I think. 26 plus 15. Wait, it's difficult. It's difficult to line this up. It's so small. Yeah, let's make it big. Let's just see. And you just use your calculator for this.
yeah.
Yeah. 4, 11, 26, 50. No, you're right. It's just because it wasn't lined up. Okay, yeah, what's next?
So now do I need to? I need to put it into the. So, um, do I need to put like height on one side of the diagram and then frequency on another?
Yeah, and which is which?
I think cumulative frequency is at the side,
Mm-hmm.
and height is at the bottom.
Yeah,
Yeah.
and let's say what are the coordinates, the plot points?
Would it be something like 4.74?
That would be for a frequency polygon.
Yeah.
For cumulative frequency?
Oh, is it always the first? Is it the last digit? I don't
Yeah,
know. 4.8.
yeah. So next one.
5, 7.
And what will be the last one?
5.84.
5.84. And so if we were to plot these, might end up looking something like that. And then
So do I now need to go on to B?
final thing is join them up.
Oh yeah, I need to draw the line. Yeah, yeah.
Straight line is okay, I believe. Smooth line is better. I'll just have to check. At GCSE they accept straight line. They might want smooth line. And there's one last thing. Technically, it starts from 4.6 and 0.
So it needs to start from a zero on the graph.
Yeah,
Or, yeah. Okay.
and so this kind of goes to wherever that would be down there. How would you do part B?
Would I do? Uh, would I look at the where the 40th giraffe is in which height, and then that'll tell me the median height of the giraffes?
Yeah. How would you do part C?
Um, Lower quartile, would that just be a quarter of? Oh, so is that like a quarter of 80?
Yeah.
So 20.
So the 20th. So the if that went up to 80, so then 40 would be go across, hit the line, go down, and then 20 would be similar. And how about this one, 90th percentile?
So that's like 90% of 80, isn't it?
Yeah.
So that would be 72.
Yeah. So this time 72. And go down. And how do you do?
Okay, so I need to for box one. I need to put the lowest value, the lower quartile, the median upper quartile, and the highest value, don't
Yeah. And so what would lowest value be?
I? Is it for one? Oh wait, is it four?
Uh, it refers to the lowest height, not lowest frequency.
Uh, so will the lowest height be 4.6?
I think that'd be 4.6. Lower quartile we just found.
Yeah.
Median we already found. What would you get for here?
The 60th term.
That's it. That's it. So you'd have to get the 60th giraffe. And then this last whisker.
5.8.
And that would be 5.8, I hope. Let's see. So this is what it looks like. Did I tell a lie? The lowest possible value for the height is 4.60. Yeah, that's what we said. 4.6. That's good. Hang on. Yeah, that's grand. So 4.60. Then they did the frequencies as 4.84. So 4.84. So the end points for each one. 40th is for the median. The 90th percentile is at 72. That's good. The data is continuous, so you do not add 1. So you could just do the 40th. And it would make almost no difference. Excuse me. That's why you don't do it. So usually for median, you do n plus 1 over 2. In this case, it would be 40.5 over 2. But the difference between 40 and 40.5 in these tiny squares, it's so little that you don't need to. And then the height of the giraffes. So it goes 4.6. We got those, and it goes up to 5.8. So 4.6 to 5.8. That's good. And I just discovered something. So I was trying to do something with I was trying to do cumulative frequency with the calculator. So I just did the stuff, but there's no on the y-axis, so it's not really helpful. Exit this. So I changed it to cumulative frequency. These cumulative frequencies are wrong. It's not lined up. But let me try something else. Graph 1. Oh, exit.
Sorry, how did you get to that? Sorry.
So this is menu statistics.
Right.
And if I go to set, I can change graph type of 1 to box plot, I think.
How did you get to set? Sorry.
So let me exit. Graph.
Right. Okay. Yeah.
So graph 1, your graph 1 might currently be set as a histogram. If I go to F6 for set, what was it called for box plot? NP plot, what was it called? Med box, median box, I think they called it. Box whisker, yeah. So we exit that and we do graph 1. There we go. And it does the box plot for us. Again, not very helpful. Hang on.
Is that from the med box thing?
Yeah.
Okay.
I just want to see. That looks very symmetrical. Very, very symmetrical. I just want to see what happens if I put in not cumulative frequency. So 7, 15, 33, 17, and 4. Delete that. Graph 1. Looks exactly the same. Okay, but it's just not very helpful. Let me see, one variable. Q1. So it's just giving estimated stuff, is it? Let me just check. The median was 5.3 and the lower quartile was 5.15. Median is 5.3 and then lower quartile is just, yeah, these are just estimates. So you need to do the graph. Okay. Any questions about that calculator stuff?
No.
Okay. We'll see if that becomes more useful later on. Let's see. What is part A for this one?
Uh, 200.
Yep. What is part C?
Minutes. So that looks to be something like 90, 80 to 88, something like that.
So, yeah, so that looks like there. So 50, 60, 70. Is it 70? It's very difficult to tell with the small squares. So it seems to go over to 70. And so approximately 70?
Yeah.
I think so. Okay, 76. So you're right. It was about 80, but if it's on paper, it's easier to see.
Yeah.
Let's see. Represented. Estimate the median. How would you get interquartile range?
Get the upper quartile, the lower quartile, and take them away from each other.
Yeah. Let's try question C.
So would that be something like 35 days?
Let's see. So that's 15. It appears to hit at about 42.
So is it 18 days or?
Well done. So for this one, you had to take it away from the total. So the total appears to be, is it 61, 62? I was going to say 62, take away 42 equals, let's just say it's roughly 8. I'll go with your one, 18. So let's say 60. How about question D?
So to get the range, do I need to do the temperature of 60 and then the temperature of 0 and then take them away from each other?
Yeah. And, yeah, go
on. So the temperature for 60 is about 20 and the temperature for 0 is about 8.
Mm-hmm.
And so 20 minus 12. So could I say for this might be wrong because the data's like, I don't know.
I believe it's because it comes from grouped data. So someone for this one could say 5.8 minus 4.6 is 1.2. But the thing is, there was probably no height that was 5.8. There might not have been, like, of these four heights, these four giraffes, maybe none of them were 4.6.
Yeah.
Maybe all four were 4.7 or 4.61 was the smallest, you know. So, so let's say grouped data, not exact or might not be exact, something like that. Let us see. Sorry, what was the ones we did? We did question C. 19 days. Okay, so the trick there was the total minus because we were going above. She is assuming that the lowest recorded temperature is 8 degrees and the highest is 20, but this might not be the case since data is grouped. The lowest temperature could actually be 10 and the highest any value greater than 18. All right. Any questions there?
No.
That's good. That's good. All right. How do we do this one?
So I feel like here you need to start from the grams rather than cumulative frequency this time.
Yeah.
So when I go up from 102 and get the cumulative frequency,
Mm-hmm.
which is about one, which looks to be about 75.
Okay. And the other one was 117.
Maybe something like 80, I think, or 90 even, sorry.
Okay. What do we do with those?
Or actually, I think that's 80, sorry. So yeah, 80. And then do I get those two uh frequencies and then like take them away from each other or something?
Yeah. So I think this one was what, 270, was it? 270 take away 80. That's 190.
Yeah.
And so that's 190 people. They said estimate the percentage.
So do I need 190 divided by 250 times 100?
Yes, that's the idea. Except I think 190 divided by the total is a 250. What does the total look like?
So about 300.
Let's see. 250, 260, 70, 280. I think it's 280.
Yeah.
280 times 100, and then you get your percentage.
Yeah.
Whatever that is. Turns out it's roughly 66%. Okay.
I got a different answer.
Oh, what did you get?
I got 67.8571.
So that's correct as well.
Is it okay? Fine.
So 67.857 percent. They're less when you're drawing a cumulative frequency diagram. They give some leeway on the numbers, and then when they give you a cumulative frequency diagram, they're less lenient. So they want the answers to be closer, but they still give something like plus or minus 0.5.
Yeah.
Okay. Because you're reading it from a graph, it's just an estimate.
Yeah.
Okay. And as well, like on paper, you're going to be more accurate. On a digital screen, even I'm looking at it and I'm just trying to like see these tiny squares. It's just the technology. Cumulative frequency.
No, I think it's it.
Yeah, cumulative frequency is all right. I thought it'd be harder. Okay, histograms. You remember them from GCSE, I'm sure. They are rectangles. Base times height equals area. Class width times frequency density equals frequency. Same idea. They said a bunch of stuff. Joining the middle of the top of each bar of a histogram forms a frequency polygon. Okay, so you can draw a dot in the middle of each bar. And then you can join them up with a line, and that's how you do a frequency polygon. So you were taking the midpoint at GCSE of the group's data and doing a frequency polygon from that.
Yeah.
Okay, there you go. So you can just do the same with a histogram. That's pretty clever. These maths guys are pretty clever. Okay, draw a histogram and a frequency polygon to represent this data. How do you do it?
Okay, so do I first need to get the frequency density?
Yep.
And so will that be 55 divided by 5?
Yeah.
So 11.
Frequency density, so that one's 11.
And then 39 over 5.
Let's put it as a decimal.
Yeah. So
I think it's 7.8.
yeah. And that'll be 13.6. 3.2. And 0.6.
Mm-hmm.
And then so now I need to do the class widths here. So does the graph start from 25? So I need to start from 25.
Yeah. So that's 25, 30, 35, 40, and so on.
And yeah, so in between 30 and 35, I need to put the other, I need to put 7.8 as well.
So what about 7.8, sorry?
Do I need to put that in as well for the 30 to 35? Or
Yeah, so let's start with the first one, 5511. What do you do with that?
so I need to go up 11 between 25 and 30.
That's it. And so let's see, this one, the highest we go up to 13.6. So we could do like it goes up to 14.
Yeah.
And well, it goes all the way down to 0.6. So you'd need the full thing. So I'll just estimate. So yeah, so that goes up to approximately 11. Okay, how would you do the 30 to 35 one?
So in between 30 and 35, just put it up to 7.8.
Yes, and because it's not a bar diagram, it's not a bar chart, it's a histogram. There are no gaps between the histograms.
Yeah.
So that one goes up to 7.8, and then you do the rest. So that's 7.8. And I believe the exam questions, and the reason why I'm doing it like this, same with the cumulative frequency, is they've never asked someone to just draw an entire histogram from scratch. What they tend to do is they tend to give you the outline of it, and there might be, let's say, missing one bar or missing one thing from the table, and so that's why I'm not putting very much effort into this. Like, this is just a sketch, and that's because they will give you the x-axis, y-axis, and you'll put the stuff on it. And actually, most of the stuff will already be on it as well. And how about question B?
I need to work out what percentage of. Do I need to work out where that data would be from, like in the time, like the class whips and stuff?
Yeah.
So that's like with the 35 to 40 and 40 to 50. And so, do I need to do? So okay. So do I need to do find out a percentage? So for example, this might be a bit weird, but do I need to do 4/5 of 68 and then a half of 32 and then add that together? Or
There's nothing weird about that. That's the exact method. 58 plus a half of 32. So that's 16 plus something. A fifth of that. It was 13.6 times 4. Open up my little one.
it's 54.4.
50.4. And so in total, is it 70.4?
Yeah.
Okay. Estimate how many students. So what would that be? How many students?
70.
Let's say roughly 70 students. Give that a go. Let's take a look. Okay, so this is... Oh, we forgot our frequency polygon. How do we do our frequency polygon?
You just draw the dot in the middle of each histogram and then join them together.
Yeah, and you would do that with all the bars.
And it has to be a line, doesn't it, when you're doing that and stuff?
It has to be what, sorry?
It has to be a straight line, doesn't it? Like
Yeah.
Yeah.
Polygon means straight line.
Yeah.
Let's see. They would say like curve or something if it was a smooth one. So that's the straight line in the middle. That's our bars. Let's see. Frequency density. Yeah. And it was roughly 70.4 students. So they left it at 70.4. Okay, grand. It was okay. Yep. Any questions about that?
No.
We probably don't need to, but oi, what happened to my calculator? No, calculator, don't go weird. It does that sometimes. Allegedly, we can do histograms with this thing. I have to say, it's so far it's not very good. Instead of median box, I assume that stands for median. We go to histogram. X thing is list 1, and the frequency, I'm going to set that as list 2, because the frequency isn't 1 for everything. Okay, just want to see if I start at 40, graph that. Is this worth doing? Let's see. No, I don't think it's even worth using the calculator for it. Okay, let's see this one. Yeah, let's try this.
So well, I say it's good to use a histogram to represent this data because there's a class width and frequency, and histogram works well with that. Or
so I believe it is because it's grouped data.
okay.
And let me just make sure. I think it's also because it's continuous, grouped continuous data. It's definitely grouped because then that creates a class width.
Yeah.
I think continuous as well. Let's see. How about B?
Histogram. They're all joined up. I don't know.
They're looking for a phrase. Area is proportional to frequency. So base times height equals area. Class width times frequency density is frequency. Area is proportional to frequency.
Yeah. So the area of the graph, is proportional to the frequency. Yeah.
So the area of the graph, is proportional to the frequency. So the area of the graph is proportional to frequency. Area is proportional to frequency. Area is proportional to frequency. So the area of the graph is proportional to frequency. Area is proportional to frequency.
Yeah.
represents a proportion of the frequency. Yep. How about question C?
Show that each day is written binary. So so 3.2 high and 2 wide, isn't that 4.6 frequency?
6.4.
Sorry, 6.4.
Okay.
But it says the frequency of the class was 8, so I'm not really sure.
So it would be proportional to 6.4. Let's see. So this one, so it's a class width of 2. So it was 3.2 high, 2 wide. The frequency was 8. If each day 0.8, I don't remember. So it's proportional. So if it's proportional, it's like y equals kx. And so k times something. What is the constant of proportionality? So when... Oh, I'll have to look this up. I'll have to look that up. Area of the bar is 6.4, and 6.4 divided by 8 is 0.8. Let me see. So it is the area of the bar divided by the frequency. Aha, and that's how you get K. Hang on. So 3.2 times by 2 and then divide by 8. So 3.2 was the frequency density.
Yeah.
Yes. So it's kind of mixing two different things. So the class width is 2 degrees Celsius, but the actual thing is 2 centimeters wide. And so that's what's being missing. That's what's being missed there. So frequency density times class width divided by frequency gives you the actual area. Okay, and then how do we do question D?
Would I need to do something like 48 divided by 0.8 to get the answer?
Say it again, sorry?
I think this is wrong, but would I have to do something like 48 divided by 0.8 to get the number of days? Or...
Go on, try it.
60.
So that would be 60 days. And that's 60 days. Yep, that's it. I'm just taking a look at this one. So proportion, y equals kx, proportional. The y is the frequency density, so that's 3.2, equals k times x, that's 2. 2, y equals k. What is area is proportional? No, area is proportional to frequency. So the area is proportional to the frequency. The area is what we wanted, but we have to get k to begin with. Oh, I won't do that. Frequency density times cumulative frequency divided by frequency. Let's take a look. Okay. Okay, let's try question 4. Wait. Is this in the right place? Yeah, it is. Okay.
Okay.
Question A.
So do I need to do something like 2 times 4.5? Do I need to basically just times frequencies and times of any numbers above 56 and add them up after?
Yeah. So what was the first one?
Would that be 2 times 4.5?
Yeah, and so on, and then you just add them up. And B.
So for so shall I get 52 to 54 first?
Yeah.
And so that would be 1.5 times, so 3,
Mm-hmm.
and then for the let's do a half times 5.5 to get the other answer.
Yeah, and then you add those up. That's good. Let's see. Okay, that's fine. Oh, hang on. Let me go back. We missed out on one thing. Question A. Temperature is continuous and the data were given in a grouped frequency table. Yes. So it's grouped continuous data. So temperature is continuous data and it's given in a grouped frequency table. Yeah. Okay. And they said the area of the bar is proportional to the frequency. I remember that from GCC. Okay, question A, this one.
Is it because it's grouped continuous?
Yep. So that is grouped continuous data. 1 mark for grouped, 1 mark for continuous. Okay. Question B.
So would the width of the bar be 0. Just 1?
And why is it 1?
Because 8.5 minus 7.5 is 1.
What is 6 minus 4?
2.
And what was the width for that one?
1.5.
How did you get 1.5?
2.5 minus 1.
No.
It's 2, isn't it?
No. It says the width is 1. So there's two things going on here. Hold on. There is the class width. So the class width is 2.
Yeah.
And then the boy who draws this thing, the bar width on the paper is 1 centimeter.
Okay.
So that's how he has fit it onto his paper. So this one down here, you said the class width was 1 centimeter. What would be the
0.
Yeah.
Okay.
And okay, how about the other thing?
Now I need to do frequency density, don't I?
Yeah.
So, um, if frequency is 8, so will it be 8 divided by 1? So 8. And in this thing, will it be 8 divided by 2?
So how are you getting 8?
7.5 to 8.5, the frequency is 8.
Oh, okay, yeah.
And do I then need to do 8 divided by 2?
And why is it divided by 2?
Because it was 4 before.
What was 4?
No, sorry. So for the class width and bar width, I thought that because the class width was 2, and I had to then divide it by 1 to 2, sorry, to get to 1 for his bar width. I wanted to do the same here.
So I think that's just a lucky coincidence going on. What's the frequency density for this one?
5.
So the frequency density for that is 5. And what height did they use? What height did they draw that bar?
2.5.
Yeah. And so that one is half as well, but I think it doesn't necessarily need to be.
Okay.
Because it's a rectangle, I don't think that they both need to be the same thing. So this one, yeah, the height would be 4. Yes, and so its width is 0.5 and its height is 4. And so it would end up with a frequency of 2, I think.
Sorry, how did you get to 4? Sorry.
I just halved it. But is that not what you said?
No, I did say that. Yeah. Sorry.
Okay. Let me just check something. Let me just check. Yeah. And what is 4 divided by 0.5?
8.
And that's what we get for that one. That's it. So you just have to compare. So it's basically the difference between what's the actual thing. So in reality, this could be like 1 centimeter across from here to here. So
Yeah.
it's just what it actually is. Width is 0.5, height is 4. It's continuous data, and the classes are of different widths. Oh, they're changing it. But grouped data.
Yeah.
Classes are of different widths. That's probably a bit better. Because a bar diagram could be grouped data. Alright. Any questions about that?
No.
Okay, so let's compare two different things. Let's just see this one. This is height. There's a number of noms. So question A is going to be fine. That's by all the noms that are for the percentage of noms. Percentage is going to be fine as well. That's just out of the total times 100. This is what the exam questions usually look like. Let's try this.
Okay. So, to start off with, what I do, so 20 to 30 would be 10. 40 to 50 would be 0.7 times 10, so 7. And 50 to 70 be about 0.3. So that looks to be like 0.3 times 20.
Yeah. I think it's 6, is it?
Yeah.
And then, is that full marks for that one? Sorry, that's copy and complete the table. Yeah, part 2.
Now we need to draw on the 30 to 40 one. So that would be 25 divided by 5 is 5. So it would go up to 5, I think.
Yeah. There's a little trick though. Is it 30 to 40 goes up to 5?
I'd say it's 35 goes up to 5.
And so for this one, you have to cut it in half. Yeah.
Yeah.
Okay.
And before that, for the 15, it would go up to 3.
That's it. And histogram, no gaps. That looks good. And then estimate the number of passengers between 25 and 38. So it'll be half of that, all of that, and then a fraction of that. That part's okay. Let's take a look. So this is what it looks like. Where was it? Frequency. So that was 10, 7, 6. That one went up to 5. That one went up to 3. Great. Any questions there?
No.
So, let's see this one. Partially completed histogram. Calculate the values of P and Q. That's fine. Who took between... Calculate the height of the bar. Let's see. Height is up there. What is meant by part B? Oh, so it's just fill in the bar. Yeah, same thing again. Same thing again. Yes, let's try this.
Okay. So y. So is y the same as like the class width?
Yep.
So I need to start off by doing. So for 13 to 14, that's 4. So should I do 20? So 24 divided by 1 is 24.
No. The class boundaries for the 13 to 14 class. So seems like the answer is 13 to 14. That those are the boundaries, but they're not, because the variable y was rounded to the nearest whole number. What can't you have in a histogram diagram?
I don't know.
You can have it in a bar diagram, but not in a histogram. You can't have gaps.
Okay.
Does that give you a clue?
So does that mean, for example, that for the nearest whole number, so would that be like 12.5 and 12.5?
So the class boundaries for this one, yeah, 12.5 to
14.5.
yeah, and so okay, I won't say it. B.
So 15 sets, is that like 14.5 to 17.5?
Yep.
And then, so should I now find frequency density with the 12.5 to the 14.5?
Mm-hmm.
And so would that be about 12?
Let's see. How did you get 12?
24 divided by 2.
Okay.
And 12 is um and 12 is 3 times bigger than I know it's 2 times bigger than 6.
Okay.
Oh, and then it asks the width, doesn't it? So is it 3 times bigger than 4 then?
Okay.
No, wait, I'm wrong.
So I would say do width first, do height second. Just kind of clearly pick one and do that.
Okay.
And in fact, they put width first, so let's do width first.
Oh, so width would just be 2.
Uh,
For this one, 15, 17. So that's 14.5 to 17.5. Would it be 3?
so that class width is 3. Of 15 to 17 is 3. And so what would be... is that the answer?
Yes.
So I think the way you'd do this is to just... you had it. So this one, the class width of the 13 to 14 one is actually 2
Yeah.
when you do it. So let's say that's let's say 2 degrees or whatever it would be, 2 degrees Celsius. But the width is 4 centimeters.
Yeah.
So for this one, the class width is 3. You are asked for the width in centimeters.
Which would be 6.
Yeah. So the width equals 6 centimeters. So like the width of the bar representing it.
Yeah.
And part 2.
So the height. Is the height like so 15, 17 class. So that's the 14.5 to 17.5 one.
So for the 13 to 14 one, what's the what does height match up with? The height of the rectangle. What does that match up with in terms of histograms?
The frequency density.
Yeah. And so what is frequency density of the 13 to 14 group?
1.
How'd you get 1?
Oh no, sorry. So 24 divided by 3. Oh no. Oh yeah, 24 divided by 2.
Mm-hmm. And so you said that one earlier, so that was 12. And so the frequency density is 12. What is the height?
So the height will be frequency divided by 12. So 2.
Hold on. The height is 6. So they don't have a page tall enough to do a 12 centimeter bar, so they did a 6 centimeter one instead.
Yeah.
And so then the 15 to 17 class. We're trying to find the height for that one.
Yeah. So will the frequency density be 6
Yeah.
and the height 3?
And so the height is 3 centimeters. That's it. Let's see. So another way to do it is like y equals kx. And basically for the first one, the k, the constant of proportionality is 2. And for the second one, the k, the constant of proportionality is a half.
Yeah.
But I think just separate them out. Say the width, so do the width separately. So the actual class width is 2, but they doubled it to be 4 centimeters. They represented that with 4 centimeters, so you just double the other one. And then again, frequency density was 12, and they represented that with a height of 6 centimeters, and so you half it. And so for the other one, you half it as well. Any questions about that?
No.
Okay, so they didn't do any y equals kx methods. They just did similar to what we did. Just want to see. That's heavier than 10 kilos. Yeah, that's the same thing as before. I just want to see. Let's see something here. Width and height of a bar. Okay, yeah, let's try question A for this.
Okay. So should I first of all just write down the information about 8 to 10 and then use it to apply it to the other groups?
Okay, yep.
So for the frequency density, that would be 8 divided by 2, which is 4. And then for the height, they doubled it, so I need to double it. And for the width, so the class width is 2, and they wrote it as a width of 1. So do I need to half that as well?
So you'd half that.
And now should I use that sort of thing to apply it to 11 to 12?
Yeah.
And so for 11 to 12, the frequency is 7. And so to get the frequency density, I need to do 7 divided by 1. So 7. I had to divide that by 2, which is 3.5.
Frequency density, does that match up with height or width?
I think that matches up with height.
Okay, so for the 8 to 10 one, what did they do with their height? How did they go from frequency density to height?
Frequency divided by class width, and then times they doubled it.
They doubled that one.
So I need to double it and get 7. Oh no, get 14. Sorry.
And so its height is 14 centimeters.
Yeah.
Okay.
And then for the width, so the class width is 1, and they halved it, so it'd be 0.5.
And the width is 0.5 centimeters. Yep. 14 and 0.5. 14 and 0.5. And the width seems easier, so maybe do that one first. Use your calculator to estimate the mean and standard deviation. So we did that before. Linear interpolation to find the lower quartiles. So we did those before. And estimate the number of days was higher. So this is kind of the mean plus 1 standard deviation. So that's just revision from previous ones. Any questions about that?
No.
Okay, and so histograms. What do you give yourself there?
I think eventually a tick.
Yeah, just took some practice. Just want to see. And then comparing data. You're pretty good for comparing data. Sorry, I just want to quickly check. Comparing the mean standard deviation. Yeah. Comparing data. Find the mean and then compare them. So we've been comparing them all along. And I think you're good. I think that's that chapter done. Yeah, how was that for you, Andrey?
Yeah, that was good, thank you.
And so, do we go on to chapter 4 next time?
I know we've just started statistics, but is it okay if we can do year 2 maths first and then come back to statistics and mechanics after?
Yeah. So year 2 pure?
Yes, please, yeah.
Year 2 pure. Yeah. Whatever the chapter 1 is in that, I don't know. Great. Any questions for me in general?
No, I don't think so.
Alright, well done, Andrey. You did great. I look forward to talking again next time.
Okay, thank you. Bye.
Goodbye.